Hey hackers, Blue Cosmo from CCS here, and welcome to Module 10 of the Introduction to Python 3 course. Today we will be talking about or covering functional programming and different types of functions, because I'm sure by now you guys are familiar with what a function is. It's something that takes an input, uses the input to do some sort of operation, and then returns and outputs it or returns some sort of value with it. So we're going to go into how we can actually create our own functions and how we can use functions to create certain types of programs and things like that. So it's a pretty cool topic. It's a very important topic too when it comes to the computer science world. So let's actually go to my screen. And I guess the first thing we can do is open up our text editor. As always, we'll be using Python idle. And we can save this blank file to our course directory, and we can make a new folder by right-clicking, hitting new, and then folder, and then we can type in our module, which is module 10. Then we can go on module 10, and we can make our new file. We'll call this file functions.py and save it. So now we have this functions.py. So functional programming is a style of programming that uses functions. All right. Now, we've covered, functions in the past. Things like the print statement is a function. Things like, the length function, if we were to get the length of some sort of list. That would also work as this is also a function. Yeah, so we've covered functions in the past, right? And a function is something, that takes in an input, runs an operation on that input, and will return some sort of output, whether it's a value or output it into the screen or whatever. So functions are typically structured as some sort of statement, followed by two parentheses, right? But in Python and many other programming languages, we can make our own functions, all right? In order to do this, we must define them. So we use the def statement, and def statement, and this def statement defines a function, all right? So we can do def. We'll call this my func for my function. Then you will have these two parentheses, and then the colon. And then within the scope of this function, we'll have this function just print hello world. Yeah, there you go. So it will print hello world. So now that we have this function defined, we can actually call it, right? In order to call it, we would do what we would do with any other function, is basically write the name of the function, followed by two parentheses, right? And if we run this, it will print hello world. So basically what this is doing is we create a function called myfunc, and every time we call this function, it will print hello world. So we can call this function twice, and if we run it, it will print hello world twice. Sorry, I never annotated this part. So here we can actually pass in an argument. So we can add arguments. Now we can, add arguments to our functions, right? So an argument is basically, we've covered arguments before, but an argument is basically data that is inputted into a function. All right. So, arguments can serve as variables. Oh yeah, so these arguments work as variables available to the scope of the function. All right, so let's make a new function and we'll call this squared. All right, and this function will take in an argument of a number. So we'll make this variable called number, and we will print the number that we are inputted, and we will square it. Hence the function name squared. Then we can call our function squared, and in our function we can input a number. So we can do like 2. And when we run it, it will square the number 2. Because when we call it, all right, let's call a function using the argument 2. It will go up here. All right, so this function was called. We'll have our arbitrary variable be assigned to the number 2, and then it will print the number, which has a value of 2, and then square it. So we can do the same thing, but instead we can do 3, and 3 squared is 9, and we can do the same thing, and let's do 4. So if we run this, 4 squared is 16. So this is, helpful. Now we can add multiple arguments to a function. So let's make a new function. We'll call this function add together. All right, and this function will take a number 1 and a number 2, and we separate arguments by commas, with commas. Separate arguments with commas. All right, and in this function, we can print number 1 plus number 2. And if we add together, if we call this function, so let's add together the numbers, I don't know, 4 and 16. If we call this function, right? It adds 4 and 16 and we get 20. So there you go. We were able to, make these functions. Now we can make our own functions. You don't have to print. You can do whatever sort of code segment or code stuff, program in these functions that you want. So let's talk about the return statement. So we can actually return data from these functions, right? So the return statement, it just returns data that can be used in operations. All right, just so you guys know, the function will stop once the return statement is executed. So let's make a function. We'll call this double. And what this function will do is we'll take a number, and it will return the number times 2. So it would basically double the number, right? So we can actually assign this value, and we can basically return the value, so that way it can be used in an operation. So if we were printing the value, it would just output it to the screen. We can't use it for anything. But if we return it, we can actually use that value and assign it to something or use it in some sort of operation. So we can do print double, double the number 2. And there you go, number 4. We can do the number 5, and we get the number 10. Now with this, this means that because we can use this as the value, because this holds the value of 10, it's not like outputting it to the screen like a print statement. This is an actual value now. So this double 5 has a value of 10 because we returned the value. So we can add this to the number 5, and we can get 15. We can subtract 3 from the number, and if we run it, we'll get 7, because we can actually do stuff with this double function. Now if we were to print it, and run this, it would cause an error. You can't, subtract. There's no type, there's no return, nothing was returned. We're just minusing 3 from something that was outputted to the screen, and it's not even what was outputted to the screen. There's no value. This holds no value. It just took in an argument and then printed that argument to the screen, or printed the argument double to the screen. But because we used the return statement, this was assigned a value, so we can actually use it for something. All right, so I'm just making that clear because a lot of people get confused on the difference between the return statement and being able to print something. So this double function right here is a pure function. The above function is a pure function. So this means it returns a value that only depends on the arguments attached. So the value of this function only depends on this n that we inputted. It's purely self-sufficient. There's no external random things that it needs to worry about. An impure function an impure function, it depends on an external value or data type. So if we were adding something to like a list that was out of here, or adding something to some sort of number that was out of here, or adding something or subtracting something, editing something directly without introducing it as an argument, this would be an impure function. So now let's talk about higher order functions, right? Higher order function. So it is basically a type of function that utilizes another function as an argument. So it's a function that uses another function as an argument. That's basically what it is, right? So if we've seen this normal looking function, right, as reference. So this is what a normal function would do, right? Actually, let me give you a better example, right? So normal function, and we can do def talk, and we'll take in a message, and then we will return the message. Then uppercase underscore message equals talk, and then uppercase I don't know why we're doing uppercase. We can just do MSG. So MSG, and then, because we can assign it to a different variable, we can just do MSG hello world. There you go. So this is like a normal function. A higher order function this would do def, and then this will take in a message, we'll say. And this message will take in a function. So we'll call it func. And we'll just do displayed MSG is equal to the func, and then we'll do hello world. And we can print the message. So if we message and then we throw in our talk function, when we run this, oh whoops, we need to print the displayed message. You can print something like this because it just returns it. So we can print the message here. Yeah, there you go. And so basically none is returned to a function that doesn't get assigned a value, okay? So if you're trying to print a function, or if it doesn't have a return value, it will output none, all right? Just so in case if you see that when you're working with functions, right? So higher order functions, it's not that confusing. Let's make a new script actually, and we'll call this text case. Call it text case.py. And basically we can use higher order functions to make our normal functions more versatile, and we can give them more functionality by doing this as well. So we can use the same concept and do output different data types, right? So let's make a title case, and then we'll do def title case, and then this will take in a text argument, and it will just return the text dot title. If you remember what that is, it just prints each substring starting with a capital letter. Then we can do def lower. We can do a lowercase function. So this will do def lower case, and then we will take in a text variable or a text argument, and we will return the text dot title. Dot lower. And this will output the text as lowercase. Now we can do an uppercase function. So we can do def upper case, and then it takes in the text argument, and then we can return a text dot upper. And then we can have our higher order function, higher order function, and with this we can just have a function called message, and this will take in a case type, and this will take in some sort of text. All right, and then all this will do is set our output to the case, and then it uses the case. So this case right here is going to be one of these functions, and basically we're going to use this function and pass in the text as the argument, right? and then we can print the output. So what this allows us to do is we can make, like, we can only use one function, and this one function will have the functionality of all these other functions. So let's make a message. We'll call it hello world. All right. And if you do message, and then we can do uppercase, and then we can do MSG. When we run this, it's going to print hello world in all capitals, because it's going to use, all right, let's use the message function, and then it will take in this uppercase argument, which is this uppercase function, and then it will take in this text argument. Then it will basically output, we'll save the output from this uppercase function to this variable, and then print it, and we'll parse in this text variable into the uppercase function. But this also means that we can use the same variable to do some sort of lowercase function. So we can do lowercase and then MSG. And we can also use the same function to do what's it, title case, and then MSG. So this one function now has the functionality of these three different functions, because it's a higher order function. So when we print this or run this, it prints the three different types of hello world, one in all capitals, one in lowercase, and one hello world. So instead of using three different functions, we can use one function and just give it the functionality of these three functions by passing in a function as an argument. So it's actually pretty simple. So we can save this, and then we'll hit Control-Shift-S, and we'll make a new one. And we'll call this special arguments .py, and we'll write this file clean. So type in special arguments. So Python has special arguments we can use in our functions, okay? And we have things called defined arguments. So let's put these here, defined arguments. And these defined arguments basically are, we are assigning default values to arguments. So let's say if we're making a function, we'll call this function profile, and we'll take in the name variable or the name argument, and this will just be equal to enter name. The age variable will have a default value of enter age. And this, let's say status, the status argument has a default value of enter status. There you go. So now we can return this name, and then we can put in the name. We can do a new line, and we can parse in the age, and we can parse in the age in there as well. And we can make a new line, and we can parse in their status, and you know, we can put in the status variable we have in here as well. So by default, if we were to return this, we would have a default value for each profile on this in this function, right? So we can say Bob's account, and Bob's account is equal to profile, and we can do Bob, and we can do 25, right? That's his name and his age. Now we can have Joe's account. And Joe's account will be equal to a profile. And his name will be Joe. His age will be 48. And he will be single. So if we were to print Bob's account, and if we were to print Joe's account, we could run this and we can see, okay, Bob name, and it gives us default of enter status, and then we have Joe who used all 3 arguments. So this basically allows you to give a default value to these arguments in case if we don't give all the required arguments to the function. All right. So the next special argument we're going to be covering is the args argument. It's an asterisk args, and we kind of talked about this argument earlier when we were talking about, I believe, tuples or lists or list comprehension. I forgot when we were talking about data structures, and it basically allows you to pass an undefined amount of arguments to a function, and it assigns them to a tuple labeled after the variable name. All right. So by default, the default is args. All right. So I'm going to explain what I'm talking about. So basically, let's make a class, right? And we're going to call this class, I'm sorry, let's make a function, not a class. Let's make a function and we're calling it class schedule. All right. In this schedule, we'll have a mandatory class, and then args. Now, it doesn't have to be called args. You can call it whatever you want. Args is just the default that people usually go for. I'm gonna leave it as args for the sake of this, but typically people will rename it. But I just want you guys to be able to identify it easily. But again, you can name it literally whatever you want as long as it has this asterisk in front of it. All right. So then we can print the first, the mandatory class. So we can do period 1, and then our mandatory class. So we know what we're talking about. Mandatory class, and then we want to finish that print statement. So we'll have a period number, and this period number is our current period, and then we'll say for course in args, we'll do print, and then we'll do the period, and then the period number, and then the colon, and we can do the name of the course. And then we can do the period number plus equals 1. Now we have that set up. We can actually make a class schedule, and in our class schedule, we'll have a mandatory class of homeroom, and then we can have math. We can have I don't know, science maybe. What's another one? English. And then we can have history. Oh, I'm sorry, I never finished this print statement. There you go. So let's run this. Oh, did I tab this for whatever reason? There you go. So let's run this. So now, ooh, excuse me. So now we can see, it took in, so let's look at this, right? We have two arguments, the mandatory class and an asterisk args argument. This argument just passed all these other undefined arguments that were put into our definition or our defined class. So all of these classes right here were assigned to this args, args argument. This args argument made a tuple labeled after variable name. We chose the name args because that's the default people usually go for. And we were able to iterate through this argument. And in this args argument were these other four classes that were just automatically put to this tuple because we didn't need to make a separate argument for all the classes that you might have, right? So it just saves on code, it saves on time, and etc. So the last special argument I'm going to go over is keyword arguments, or quargs. All right, and quargs argument passes defined arguments into a dictionary labeled after the quarg variable name. Now we can actually make our class. So we can do def groceries, give it a argument for a store name, and a area for the keyword arguments. All right. Now again, you can call this whatever you want as long as the two asterisks are there. So we'll do print, and then we'll do a new line, and then we'll add the store name. And then we'll do for food price in the keyword arguments dot items. We could print an f string, and we'll just call this f string food, and then we'll show the price for that same food item. So now we can go on to groceries, and we can do let's do giants, and let's say they have apples, and they are equal to do $1.50, and they have oranges, and they are equal to, let's say, $2.50, and we have bananas, and these bananas have a value of $1.75. All right, I don't know the actual prices at Giant, but it's just hypothetical, right? So let's make another one. We'll call this Publix, and we'll do apples, and this equals to $1. Then we can have oranges, and this will be equal to, let's say, $3.50. and then we can have bananas, and they are equal to $2. And that's it. So what is this doing, right? So we have a function that will take in a grocery store name and then some keyword arguments. And if you don't remember what these defined arguments are, we covered them up right here, right? So, and it will take these keyword arguments and assign them to a dictionary labeled keyword arguments, or whatever you decide to call it, right? So this will then print the store name, and then it will iterate through our dictionary and print the food and the price, or the key and the value within the dictionary. So let's run this, and we can see it printed Giant, which is the store name, then the prices for the items at the Giant grocery store, and then we have Publix, the other grocery store, and the values that they are selling their products for. I don't know how accurate these prices are. This is just a program. All right. So the next thing we're going to get into is actually, we can save this program, and we're going to make a new one, and we're going to call this main.py. Main is actually pretty cool. All right, so it allows our code. So underscore underscore main underscore underscore. It basically allows your code to be both imported into other projects or run as is. All right, so we use the conditional. So this conditional call, or the conditional, how do I label this? If underscore underscore name underscore underscore it is equal to, in quotes, underscore underscore main underscore underscore. So this this conditional right here, so the conditional below detects if the code is being ran or imported. The attached expression will be run if the code is being run. And then in here we will have our expression. So let me give you guys a visual example, right? Just so that way you guys can get some more clarification. So we have our main.py file here already. So let's make a new file, and we'll save this file, and we'll call this file script.py. So what this script.py file is going to do is we're going to make a function, and we're going to call it double, and then we'll take in a number value, or a number argument, and we will return the number multiplied by 2, so hence doubling it, right? Then we'll have this main function, right? And this main function will basically be the main code. So we'll just call this main code. And what this will do is it will do print an f string to doubled is double, and then we can do 2, and this that, I believe. All right, now we can say at the very bottom, if name is equal to main, which means if this is the main file that's being run, then we can run main.py. We can run the main function. So if we run this script, it will print 2 double is 4 because this is the main file that we're running. We are running this file. It's not being imported, it's not doing whatever. However, we can go over here and we can do import script, which is the name of the file, and we can print script dot double, and then we can print 4. So if we do this, we get 8. So basically, we took the script, this is the name of the file, script.py, so we import script, and we're able to use this function in a different file, which means you can write your other code or other programs and use those same functions in your other programs. This is similar to how the random module kind of works, right? Or the other modules work. We'll get into this like in depth in module 11, but I just want to give you guys a kind of overview on how we can import scripts or import modules, import functions from other programs. Cool. So I'm gonna close this and we'll control shift S, and we're making a new file and we'll call this map filter.py. You can delete all this. All right. So we're going to be talking about mapping and filtering. So the map function basically allows you to use each item in a list as an argument to a function. So let's use this double function we've been using, and we can basically return the n times 2. So we can do numbers. Let me go down one more line. So numbers equals a list of 1, 2, 3, 4. Then we can do our mapped list and have it use our map function right here. And then we can parse in each item of this from this list into the function called double. Now we can print the list version of this mapped list. And if we run that, we get 2, 4, 6, 8, because it goes through and the map will basically use this function and then take each item from this list and input it into this function. So now we get a list of, we take the list 1, 2, 3, 4 and double all of its values. So I'll do print map. All right, so now let's cover filtering. So filter is another function, but it iterates through a list and it only returns a value if it follows a condition. All right, just like this, the first argument is the function and the second argument is the list, right? So we can do def, we'll do even, and this will take in a number, and then it will return the value, n modulus 2 equals 0. And if you guys don't remember, this Boolean value, or this Boolean operation, or conditional, or Boolean logic, will only return a value if a number is even. So we can do numbers equals, I can actually just keep the numbers variable we have up here. So we can do filtered list equals filter, and then we can pass in this even function, and then we can pass in our numbers, which is our iterator or iterable, and then we can print the list version of the filtered list. And when we print filter, oh, I never finished the print statement, and I never added a closing parenthesis. And there you go. So map will double all of the values in here, and map will basically go through each item in here and pass it as an argument to this function. Filter, it will do the same thing, but only return a value if you can add a filter. Basically, you can only return this value if it's true. So you kind of pass in the function while you're iterating through a list. All right, so let's save this file, Control-Shift-S to make a new file. We'll call it lambda, lambda.py. And we'll delete all this content. So we'll just type in lambda, and the lambda function is basically a less powerful function that works in one line. It can take many arguments, but it only returns one expression. So if you're making a function that's going to have a bunch of lines and multiple lines, something like a lambda is not going to be helpful. But otherwise, we can, shorten our code. So let's show like the normal function, right? Normal function, and the normal function will do def double, and it will take in the n value, and we'll basically just return the n times 2. Now our lambda will do this exact same thing, except it will do it in one line. So the default variable people use for x, or for the default variable people use for lambda is x, and this will basically, this right here is the lambda function, right? So this is the argument right here, and it will basically return this expression. This does the same thing. So this is the name right here of the function. The lambda will take in this parameter, which is going to be n, and it will return x times 2, and this also returns x times 2. So it's the same thing, just shorter, really. So now we can do double 2, and if we run this, well, I need to print it. This is in the module, so we can print it. And there you go, module 2. If we print double 2, it will output our lambda value. We can do double Let's do double 4. I don't know why it's doing that. So if we do double 4, it's 8. If we do double 5, it's 10. So these functions do the same thing, but this function does it in a shorter scale. I'll just call this double n, just to show that these do different things. So print double n, and we will put the value of 2 in here. So when we run this, we both get 4, but they both do the same exact thing, except this does it in 2 lines and this does it in 1 line. Now lambdas can take more than 1 argument. Lambdas can take more than 1 argument. So we can do add together, and we can put in our lambda with the value of x, y, and we'll have it be equal to x plus y. So if we were to print add together, and then we'll do 4 and 6, that will be 10. Oh, not equals, I'm sorry, colon. Add together is not defined. Add together, add together, together. There you go. And there you go, we get 10 because the add together lambda function, we are inputting 4 and 6 as x and y as these arbitrary arguments, and then the lambda will return x plus y. So the value that gets returned is x plus y, so we can print that out as 10. Now lambdas aren't always assigned to variables. You can use them in functions. So if we wanted to, we can do lambdas can be assigned to functions. All right, so we can do something like a num list, and this num list will equal a list from the range of -10 to 10, and we'll just say positive values, so positive nums are equal to the list version of filter, and we're going to, instead of parsing in the name of a function, we can just parse in the lambda, and we'll do lambda x, and then if x is greater than 0, because that would mean it's a positive number, then we can go ahead and parse in the num list as the second argument for the filter. So when we print out the positive nums, positive nums, make sure you spell it right, it will print out 1 through 9. Now, I'll just do 1 through -10 through 11, just so it's -10. So this printed out all the positive values, rather than printing out the list, which goes from -10 to +10. So that's going to be it for the actual note-taking part of functional programming. We're going to do a project, and we're going to be making a minimal calculator. Right? It's not going to be a full-fledged, complex calculator. Although I have made one on my channel before, it was pretty cool, and also that calculator could like hold files for you. It was like a secret vault, basically. I'll probably link it in the description if you're interested. But it was like a 10-hour live stream So don't feel like the need to watch it all. But we're gonna make a new project. We'll call it calculator.py, and this is the practice. So if you want to try to make this project on your own, then you guys can go ahead and leave now and go ahead and try it. If you guys are stuck, or if you guys want to walk along or do it with me, then you guys can feel free to stay. And if you guys need if you guys need any more ideas on how to do the if you guys need any more project ideas, you can try. You know what? I'm gonna use normal functions for this. I want you guys to try to see if you guys can use lambda functions for this program. And I also want you guys to see if you guys can, I don't know, add a creative take to my calculator program that we're making. All right. So we'll call this calculator, and we can add our created by, and then our name. Feel free to put your name there, and so we'll just do a an addition function, and then we can do def addition. And then we can take a number 1 and a number 2, and we can return num1 plus the number 2. So we can do the same thing, but for subtraction. And if actually what I'm going to do is copy this, hit Control-V, Control-V, all right? So now we can make our subtraction function. We're going to make our multiplication function, and we're going to make our division function. So our subtraction function will be called subtraction, and it will do the same thing, but it will subtract. Here we can do our multiplication function, and this will multiply the values, and then this will be our division function, and this will simply divide the values. Cool. So let's loop our code. Loop code in case of exception, and we're going to make our while true, and this will just run the code infinitely until we break it. So we will have our banner, and in here we can print a simple calculator, and we do a little colon, and then new line, and then end the print statement. And then we can make our option menu, and our option menu will print, and we can choose an option. Whoops. We can choose an option, or actually we can choose an operation, and this will be a new line and a tab, and we'll have option 1, which will be addition, a new line and a tab, and this will be subtraction. This will be a new line and a new tab, and this will be option 3, and we'll call this multiplication. And then we'll have a new line and a tab, option 4, and this will be division. So we can close that off. Oh, let's actually make a new line after the division just to make it look cleaner. So now we can get user input, and this user input will be the operation. So we can do operation equals input, and then we can have the word option, colon space, and there you go. So now let's try to get numeric values. So we're going to do a try statement right here, and we're going to get user input for the numbers. So we're going to have our first number, and this is going to be equal to the float, because we're going to use floats to do math. That way the math equations will be more accurate, because if you can't, if we're doing like division or something, if it's an integer, then you know, there are going to be some problems. It's going to output it as a float. So if we use floats throughout the code, they won't have to worry about any errors happening or anything like that. So we can do enter their first number, and that whoops. There you go. So we can do our second number, and this will be equal to a float input enter second number space colon space, and we can end the print statement. And of course we can do addition. So if operation is equal to 1, we can print an F string, and we can give them the first number, and then we can do plus second number, and we can say is equal to the addition function with the first number, comma, the second number. And we can close this value. All right, and then we can go ahead and break. Oh, I never put a colon here, whoops. So tab that over, and we're basically gonna, copy this, and go ahead and tab that over here. So here will be our subtraction, and basically if option is equal to 2, it will subtract, and then instead of using addition, it will use the subtraction function. And for here, we can use the number 3, and this will be multiplication. And we can actually, first of all, we'll do multiplication. And if you're on Windows, you can hold Windows key period and get access to special symbols. So we're going to do the multiplication symbol right there. Awesome. So and I'm pretty sure if you're on Mac, you hold down Option, and then you would hit the asterisk, I believe. Now on this last one, we can do division, and this operation is equal to 4, and it's basically, we can hold down the Windows key, hit period, and we can use the division logo, the division symbol, and then we can do division on this program right here. So now we need to make these elif statements, and then we can have our else statement. There we go. So we're going to say exception. We can say else, and then we can print input was invalid. Try again. And we can try to throw a little new line after there. Close the parentheses and then continue the loop. Now, the last thing we need to do is add the actual exception. So here we can do exception, and we can do except value error, because if they put like a string instead of a float, or an integer instead of a float, then it will convert it for us or handle it for us. So error, well, instead of a numeric value, that's right. So we can we'll be fine if you put like a integer in there. So we do enter a numeric value. And in this list, we can do 1, 2.5, we can do 7, etc. Then we can make a new line here, close off the print statement, and that's it. So that's our calculator done. So we can run this. Whoops. There you go. I'm assuming we probably have to do this for every single one of these. Whoops. So let's go through here. Make sure I don't have to add. No, I do. Okay. So put the closing parenthesis in here. And if I run this, so we have our simple calculator, choose an operation. Addition, subtraction, multiplication, and division. We can choose addition. Enter our first number, we'll do 5. Enter our second number, we'll do 9. In name of addition, additon is not defined. Where did I put additon? There you go. Addition. So if I run this, we'll try this again. So we can enter our first number. We'll do 8. We'll do 4. And then it'll say 8 plus 4 is 12. That's awesome. All right, there you go. So you have an actual calculator. So we can do, let's do some multiplication. And we can say number 9, and then the number 4. And then 9 times 4 is 36. We'll do one more equation, and then we can do division. Let's do 100, and we'll do 20. Divided by 20 is 5. So there you go. You have a full functioning, simple calculator. Now, if you want, you guys can replace these with lambdas. See how well you guys can get familiar with that. You guys can pretty much optimize this entire project. You can use higher order functions instead of using these individual functions right here. There's a bunch of other options you guys can do to make this program a lot more advanced. So I encourage you to make this program a lot more advanced. But that's actually going to be it for me. So if you guys want to head over to the next module, we certainly can, which is going to be module 11, which is object-oriented programming, which is also the last module of this course. So once you go over to that module, once you finish that module, you're going to be done with the course. You're going to be you will have officially known Python as a intermediate user. So I will see you guys over there. But if you guys are taking this course on YouTube, then make sure to leave a like and subscribe. You guys can head over to the website and check out the same exact course, but on the website. But on the website, it's a lot. The interface is a little bit easier to understand. All the modules are there for you. You can kind of keep track of your own progress. You can even quiz yourself to see how much you know. And if you want to, you can choose. You can enroll officially into the course for a one-time price of $15. And you can get a certificate once you guys finish the completion, so you can show it to your friends, your family, and good for job applications, resumes, etc., to show that you completed a Python 3. So that's it from me. I will see you guys in the next module. So stay happy, stay positive, and as always, happy hacking.